Hello, scholars. This flip will discuss question number 1 from ELG Unit 7 on density. We're going to start with a joke. What is red and smells like blue paint? Red paint! Oh my gosh, so funny. Okay, so question number 1 asks us, let's read the question. A scientist finds a clump of mysterious metal on her laboratory floor. It has a mass of 685.8 grams. The scientist drops it into a cylindrical container. So I'm imagining my clump of metal. I don't know what material it is. And I'm dropping it into a cylindrical container, which causes the water level to rise. It tells me 1.3 centimeters. The radius of the base of the container is 4.0 centimeters. I think that's important. Use the table below to determine what type of metal the scientist has found. So I'm using this table, and I'm trying to figure out what type of metal I've dropped into this cylindrical container based on the displacement. Displacement, remember, is when we drop something into a container, it causes the water level to rise. Think of yourself getting into the bathtub. The water level rises. The volume of the water that rises is congruent to your body's volume. And we're supposed to explain how we know what kind of metal is on the floor. Okay, so first I'm going to draw the situation. I have a cylindrical container. Kind of looks like this can of kidney beans. Well, that's a terrible cylinder. I'm sure you guys can do better. And I have this mysterious clump of metal that I'm going to drop into this cylindrical container. This container is full of water. It doesn't really matter how much water is in here, but what does matter is after I drop this clump of metal in, what's going to happen to this water level? It's going to rise! Do we know how much? Yeah, it tells us, 1.3 centimeters. So I'm going to draw the new water level. So this is a distance of 1.3 centimeters after this clump of metal is inside. So this is one of those problems that relates density, volume, and mass. Density equals mass divided by volume, I know. Okay, what do I know? Well, I'm trying to figure out what type of metal this is. It looks like I'm going to maybe be using the density of the metal to figure that out. So once I know what my density is, I can figure out what type of metal this is. If I can figure out the mass of this metal and the volume of the displaced water, so that disk of water, I can figure out the density of this metal. So let's see, mass of the metal. Oh, it tells us. Oh my gosh, it's so important to read the problem. It says this metal weighs, if you were to put it on a scale, it would weigh 685 and 8/10 of a gram. And I'm including my unit as a G. Can I find the volume of the water that's displaced? Absolutely. Remember, this is like a little disk of water, a little cylinder that has a height of 1.3 centimeters. What else do I need to find the volume of a cylinder? Maybe I'll write this equation down here. Volume of a cylinder equals area of the base. I have a circular base. Remember, cylinders have circular bases, so I know the area of a circle is pi r squared. And I know that to find the volume, I need to multiply that by the height, or the distance between the bases. So I need height and I need radius to be able to find the volume of this disk. Well, I know the height is 1.3 centimeters. That's the displaced water. Do I know the radius? Yeah, it tells us right here. The radius of the base of the container is 4 centimeters. Radius extends from the center of the circle to the edge. That's 4 centimeters, and that's my radius. So I'm going to plug those numbers into here. Volume equals pi times my radius is 4 squared times the height of 1.3 centimeters. Now I'm only squaring my 4 here. I'm going to do 4 squared, or 4 times 4, and then multiply by pi, and then by 1.3. So I'm going to rewrite this as pi times 4 squared is 16, okay, 4 times 4, times 1.3. I'm going to plug all that into my calculator. Love this thing. Okay, remind me, what are those numbers? I always like to do pi last. So 16 times 1.3 times pi, or if you don't have this calculator, you could always do 3.14 as your pi value. Enter. What do I get as my volume? And we're talking about the volume of this cylindrical disc, or the displaced water. 65.3, what's my unit? Volume, 3 dimensions. I'm working with centimeters. Centimeters squared would give me the area of the base, times another centimeters for the height. That's going to give me centimeters cubed. So the volume of that displaced water, or the volume, so that, remember, the volume of that disk of water corresponds to the volume of this clump of metal. It's like when you get in the bathtub. Pretend this is you getting in the bathtub. The amount of water that the level that the water rises, the volume of that disk, is equal to your body's volume. Same with this clump of metal. So if the volume of this disk is 65.3 centimeters cubed, so is the volume of the metal that we drop in. If we know the mass of this metal, remember they told that to us up here, and we know the volume of the metal, which we found using displacement. Remember, there's no formula to find the volume of a clump, so we had to do it using displacement. So if we know these two things, our mass and our volume of our metal, we can find the density. Mass divided by volume will give us density. So let's see if when we do that, it will equal the density of one of these metals. 685.8 divided by 65.3 equals, oh my gosh, would you look at that, 10.5 grams per cubic centimeter. For every cubic centimeter, so imagine like a little Rubik's Cube block, for every cubic centimeter of this metal weighs 10.5 grams. And our density is written then as 10.5 grams per centimeter cubed. What type of metal is this? It's not gold, but it's silver. Yay!